Greetings, Saintsmen. This is lesson 6.6, Inequalities in Two Triangles. This is going to be the last lesson for the semester here that is going to be graded and live streamed. So I have for you guys what's referred to as actually the hinge theorem. It is both the SAS and the SSS hinge theorem. And something I just want to make sure that I really actually don't care if we mix the two of them up, but more so that we're able to identify what the hinge theorem actually is, right? The key is this hinge. So in class, you saw me demonstrate the angle side relationship. And when I showed you guys using a yardstick and a slide rule, a 1 foot and a 3 foot length, and showing that we were going to have a maximum that we could actually open up our angle. And what's demonstrated then is the angle side relationship, that angle that is opposite the longest side is going to be the biggest angle, right? Now, here's how the hinge theorem effectively works. We're going to have two triangles, and these are not congruent triangles, okay? I have triangle ABC and DEF, and I have two sides. Now, there's an included angle here, right, for angles B and E. And for angle B, it's going to be equal to 50 degrees, and angle E is going to be equal to 60 degrees. The question then becomes, which, not just side is going to be, or angle is going to be the greatest, which is pretty straightforward. Obviously, it's going to be 60, it's bigger than 50. But which of these two sides that is opposite going to be the biggest? And do you know what it is? Since these two sets of sides are congruent, simply, we just look at the angle or the side opposite these angles that are included, and we can make the same determination correspondingly. So AC is going to be the smaller of those two. So AC will be less than DF. All right. Now, for when we do this for the side, it works like this. Again, we have two triangles. We have ABC and DEF. And given again that we have two sets of congruent sides, all right? But the given value is actually going to be a value with regard to AC and DF and those side lengths and how much they're worth. So AC is going to be worth 11, or is going to be a measure of 11. DF has a measure of 12. So the question then becomes, which angle is bigger, angle B or angle E? And that determination is made by, you take the side opposite, and then you go to the angle opposite. Angle B is the smaller angle because it is across from the smaller side. All other things considered being the two sets of congruent sides. All right, so last but not least, we have a proof to complete. And this is an actual direct proof, two-column proof. Back to kind of the tradition of what we have done previously. So we have triangle A, B, C, and then we have this point D that's on here, okay? And the only thing that we're given here is that AB and BC are congruent, all right? So, our given is that AB, oops, got a little smear here. AB is congruent to BC. The other given here is that AD is a side that's greater than DC. So the question, or the thing that we're going to have to prove, and being explicit and taking all the steps, even though I think you guys are going to see it right off the bat, is that we have measure of angle ABD, and it will be greater than the measure of angle CBD. Okay? So it's this. We have our two columns, so we have to start. Left column statements, as always. The right column is reasons, as always. And again, our first statement is provided right here. So we're going to just copy that exactly, and we can just get those points, right, on your next exam. If we knew nothing else. And we know how this is going to terminate, right? We know this is going to be our last step. But we're going to have one more step we're going to have to take in between. Oops. And of course, our first reason is the given. All right. So, number 2. Well, I think that you guys already see where this is going. which is that we need to show that this angle here, ABD, is bigger than this angle here, CBD. And we were already told that this right here, AD, is bigger than this right here, DC. Now, for us to apply this theorem, we'd have to have two sides, sets of sides that are congruent, and we have BD. That's going to be the simple one for us to look for, right? It's that low-hanging fruit, and the one that you guys are able to do where the reflexive property, kind of the one that I hope that kind of jumps out at us. And now, because this is the case, right, we have these two sets of sides are congruent, and then we have the relationship, dictated about um, the sides opposite these angles. We now can say that the measure of angle ABD is greater than the measure of angle CBD. And the reason why is because of the hinge theorem. And this is technically the SAS hinge theorem. But if you mix those up, I actually don't really throw a fit about it. You need to make sure you have this term hinge in there. Okay? That is all. I will see you in class. Good luck.